Hello everyone! Today we want to present about energy storage. What is the energy storage? Energy storage in a broad sense is thought of as a technique dedicated to storing and discharging electricity. The significance of energy storage is to meet the short-term fluctuating energy demand requirement. Second, supply energy during transitory power disturbance. Third, improve operational performance of energy system. And lastly, provide energy security with less environmental impact. Next, types of energy storage. It can be classified into four major types. Application requiring low power in isolated region for supplying energy to the transducer and terminal means for urgent situation, and application requiring medium power in isolated regions. Applications requiring peak load leveling and application requiring power quality control.
Next, we will explain about characterizations, properties, and design. Characterization based on physical nature. First, mechanical or thermal. Second, electric or magnetic. And third, nuclear. There are two processes of storing and delivering energy, which are first, charging and second, discharging. Charging or discharging time. First, long times, minutes to many hours. Second, short time, second to minutes. And lastly, very short times, less than a second.
There are five classifications of energy storage system: mechanical system, chemical system, electrochemical system, electrical system, and thermal system. Let's talk one by one. First is the energy storage by mechanical system. The concepts of enabling kinetic and potential energy storage through a mechanical system can be performed using flywheels, pumped hydroelectrics, and compressed air energy storage technologies. For flywheels, kinetic energy is the key source for flywheels to store energy mechanically. The flywheel is coupled with the electric generator assembly for energy storage, and the entire flywheel system is placed in a low-pressure atmosphere to reduce shear disturbance loss due to wind or external forces. The flywheel system operates on the principle of kinetic energy for storing and releasing energy depending on load demand. During the storage period, the flywheel system rotates at very high speed by means of electric motor activation, and during the discharging cycle, the stored kinetic energy in the flywheel is utilized for generating the motor to function as an electric generator. Pumped hydroelectric storage. The potential energy of water stored in two reservoirs situated at different heights is utilized for the generation and storage of electrical energy by means of turbines and pump facilities.
Pumped hydro is a supplement to a standard hydropower plant that stores energy by running the water turbine backwards. The most significant advantage that pumped hydro offers is probably the large amount of energy that can be stored.
During the low demand period, the water from the lower reservoir is transferred to the higher reservoir by pumps, and during the peaking or high demand period, the water stored in the upper reservoir is allowed to flow through the turbines to generate the required electricity. The storage capacity of the pumped hydro system depends on two key parameters. First, height from which the water falls, and second, the volume of water required for the process. A mass of 1 ton of water that is falling from the height of 100 meters can generate about 0.272 kilowatt-hour of energy. And last energy storage by mechanical medium is compressed air energy storage. Compressed air energy storage is considered to the other commercial available technology, which has the ability to provide very large energy storage capacities next to the pumped hydroelectric storage plant. Let's watch the video how compressed air storage works. When energy is to be stored, off-peak electricity powers the motor which drives the compressor. The compressor draws in air and compresses it, increasing the pressure of the air. The compression of air releases heat, leaving cooler compressed air. The cooled compressed air is stored in sealed underground chamber. Pre-existing structures such as disused salt mines can be used. When energy is to be recovered, the high-pressure air is first released through a heating system to start the expansion of the cooled, compressed air. The expanding air spins the blades of expansion turbines. Some plants warm the air at this point using natural gas. And lastly, the generator converts the spinning motion of the turbines into electricity.
Electric and magnetic energy storage. Energy can be stored electrically and magnetically, including batteries, fuel cells, capacitors, and magnetic fields. Batteries. Electric batteries were one of the first man-made sources of electricity. Today, batteries are very important for portability or independence from the electric grid. One of these implications are electric battery power car. Superconducting magnetic energy storage (SFTS). SMES stores electricity from the grid within the magnetic field of a coil comprised of superconducting wire with a near-zero loss of energy. A grid-enabling device that stores and discharges large quantity of power almost instantaneously. Benefit of SMES: first, improve power quality. Second, improve load leveling between renewable energy sources. Third, environmentally beneficial. Fourth, enhanced transmission line capacity and performance. And lastly, ultra-high field operation. Nuclear energy storage.
Nuclear battery use the heat from the radioactive decay of some isotope and use it to generate electricity using the thermoelectric effect. Nuclear batteries have been used for many years, mostly in applications needing very long lifetime and high energy density.
Nuclear batteries. Nuclear batteries use the heat from the radioactive decay of some isotope and use it to generate electricity using the thermoelectric effect. It widely used in high energy density such as outer space or underwater battery systems. It causes less environmental effects compared to existing batteries. This is the image inside of nuclear battery. This is the image of nuclear battery next to a USB full scale. As we can see from here, that the size of this nuclear battery is so small. Environmental impact of energy storage. First, a large amount and wide range of raw materials, including metals and non-metals, are used to create energy storage that will limit the resources of these raw materials and create tangible pollutants. Energy storage can generate considerable amounts of environmental pollutants. For example, hazardous waste, greenhouse gas emissions, and toxic gases during different processes such as mining, manufacturing, use, transportation, collection, storage, treatment, disposal, and recycling. Conclusion. The importance of energy storage. First, to improve the efficiency and quality of electric power generation. Second, to provide a backup power in the event of blackouts. Third, to provide power to portable devices and vehicles. And lastly, to make it possible for renewable energy sources to be used more effectively. This storage is best suited to a particular application based on efficiency, lifetime, reliability and safety, temperature dependence, and storage capacity. Thank you everyone for watching our video. Hope you like it.